All right, welcome back. Happy today. We're going to delve further into toxicology with part 2. This video is going to focus mainly on postmortem toxicology. There are so many vids scattered across YouTube about symptoms and treatments and how to deal with a living victim that I'm not going to touch on that too much. SciShow alone has half a dozen of them, so highly recommend you look those up after this one. So you have a person who's dead. It's suspicious, so you do an autopsy. You suspect poison. So, what do we do with this information? Many people think that there's this machine that you pour a sample into and it spits out the answer. And unfortunately, this does not exist. We do have a pretty nifty machine that gets us pretty close, though. Gas chromatography mass spectrometry, or GCMS for short. It spits out answers like this. Any chemistry undergrad can tell you that this is some kind of alcohol. And they're right, it's ethanol. Ethanol is used for disinfecting, enhancing fuels, and getting wrecked. Different alcohols have very similar readings, though, just like anything with similar structure will have similar readings. And this is just a couple of different things. This is what a typical human urine sample looks like. It takes a chemistry wizard to interpret this, and even that might not be specific enough. So this is a panel, or one that's similar to run on nearly every autopsy. You have alcohol, analgesics, antidepressants, antihistamines, antipsychotics, benzodiazepines, cannabis, cardiovascular stuff, cocaine, narcotics, and stimulants. What's not on a routine test is literally everything else. So you have to have some kind of sense of what you need to test for if nothing comes up on your standard exam. And how do we do this? We look for signs. We smell for signs. We touch and feel for signs. No, we don't taste. All right, so next I'm going to give you a few examples of poisons with distinct postmortem signs. You want to say hi? Come here. This is Tiny Dancer. She wants to say hi. All right. So these examples have distinct signs. If you can get a medical history of the symptoms they are having prior to death, that's awesome. But you probably, well, you might. But for now, let's assume we don't. So starting off, cyanide. Cyanide is found naturally in seeds and nuts like apricot pits and apple seeds. And how it works, you remember that electron transport chain from back in biology where you get most of your energy? Cyanide goes and throws a wrench in it right towards the end and blocks you from getting that precious, precious ATP. So this means you can have all the oxygen that you want, and it's not going to do anything. Your cells can't use it. So during autopsy, if you suspect cyanide, keep a nose out for the smell of bitter almonds, especially in stomach contents and kind of around their face. Like, I even read a thing if you like kind of push down on their chest and smell what's left of their breath. Never done that personally, but it makes sense. Carbon monoxide. Your red blood cells carry oxygen around like passengers on a bus. They get on at one stop, being the lungs, and get off at another, being the tissue. Carbon monoxide fits into the red cell even better than oxygen does. Like those mean passengers that refuse to give up their seat, and these ones never even leave the bus. This means that oxygen can't get to the tissues that need it. Also, a sign to look for is a bright cherry red lividity. I've seen victims of carbon monoxide poisoning, and yes, they turn bright red. Phosphorus, or compounds that release phosphorus. It goes in and steals calcium right out of your cells and turning it into calcium phosphate. Now, not only does this rob your cells of calcium that they need to use to function, but calcium phosphate makes these really sharp crystals that get stuck in the tissue that tear it and clog it, and organs will kind of harden and stiffen, and it's a mess. Things to look out for: phosphate will smell of like onion or garlic, kind of, and it turns the stomach contents this dark coffee brown. Barbiturates. So in your brain, you have these receptors for a compound called GABA, or GABA. It's an acronym. I personally can't remember what it stands for right off. I just always hear it as GABA. This makes you feel relaxed. These receptors have these gates, kind of like doors, that are free to open and close as needed. So you just get a little bit at a time. Barbiturates hold that door open, leading to more GABA being let in, making you very tired, sometimes to the point where you're acting intoxicated, and even enough that it can slow your breathing to a stop. So fluid in the larynx is a sign of barbiturate overdose as well as alcohol overdose. Sulfuric acid, it wears holes in your digestive tract. Like it just burns these ulcers in and goes right through, and it's terrible. You'll notice distinctly black stomach contents, and the digestive tissues will also be stained black. Arsenic, a classic. So this derails enzyme function by replacing phosphate groups. So you have phosphate groups on these molecules that work with the enzymes, and arsenic takes the place instead, and then it doesn't quite fit anymore and processes don't work. Some signs of arsenic poisoning are what's called Mises lines on the nails. They're these little white lines that go across, like in the picture, as well as a fatty liver. It's one of several things that can cause a fatty liver, but if you see both fatty liver and Mises lines, think arsenic and go run a test on it. Mercury also janks enzyme function. It affects the kidneys a lot, and it will make the tissue kind of crumbly. It really damages it to the point where the tissue can't even stay together. So if you touch a kidney and it starts falling apart, think mercury. Copper. This disrupts the liver and kidney function. Some signs to look for with that is what's called a Kaiser-Fleischer ring, which is this coppery looking ring around the iris. And it also adds kind of a bluish tint to stomach contents. Not nearly as blue as I made it in the picture, but oddly blue for what you would think of as stomach contents. So that's all I have for today. Those are the ones, like I said, with really distinct post-mortem signs, and that can give you more direction on what you need to test for, because you can't just test for all the things. I've had requests for, families saying this is suspicious, I don't think this was a heart attack, can't you test for poison? Well, yes, but no, because we have to have an idea of what we're looking for. That GCMS can help by telling us the general shape of a molecule, but that doesn't narrow it down specifically. What you really need is a definitive idea and then test to see if it's positive or negative. So until next time, I'm planning on doing one more video on toxicology, kind of a 1.5 going further into LD50, and why we use LD50 and not LD100, and why that's statistically inaccurate. So, farewell, till next time.